center with the same acceleration.
Exactly.
Now this is okay. Now since you are asking me to explain about gravity, so let us come to gravity.
Sure.
So I'll write a simple formula given by Newton, which he never proved. He took it as it is. As it is.
One thing I would like to
Empirical.
no.
Yes, yes.
Actually, one thing I would like to add that that's 1 by r square, no, not from there. 1 over r square. This formula was actually given by the Hooke, Robert Hooke.
Actually,
Because he was writing something r to power n.
he was actually generalizing it.
Yeah, but what exactly n is, he didn't know.
So Newton wrote an empirical formula doing various experiments which were conducted by Newton and Galileo.
And many more, yeah.
They came to the conclusion that this gravitational force between two bodies is proportional to the product of masses.
Yep.
Individual masses, and this Fg is actually inversely proportional to the distance. And this is a normal observation also, that the bodies which are very far away, they exert less force. The bodies which are very close together, they exert more force.
Yep.
And the more the mass, the more the inertia, the more the force. Actually, he introduced this. Newton didn't introduce this ad hoc. His inspiration was actually his inertia. Inertia never left his mind. So he said that, and we'll understand this on the basis of falling bodies. That bodies fall on the surface of Earth with this acceleration. There are two ways to explain this. Actually, three, including Einstein. Three.
Yep.
So we'll take first explanation based on Newton's equation. Then we'll take the second observation based on inertia, which is very intuitive and very physical. And then we'll take the third explanation, just a passing by comment according to Einstein. Let's take this. And we'll understand gravitation in a very intuitive way.
That is really good.
That is the gist. So let's see. So he wrote this, and then he said, okay, there is a proportionality constant which comes, and that proportionality constant is some value. That value we included, and he called it as gravitational constant, which is capital G. So that becomes m1 m2 upon r square. Now this is very good.
You forgot to mention one thing. This negative signature. Negative signature, of course.
Yes.
Because this is attractive force overall.
No. So this is a central force. This is an attractive force. Those things are there.
And that is very important point. That's what I'm saying. Because we have to mention that the gravity is always attractional.
No. So this is very obvious that along with this, there is one very specific statement attached, and that is two lines. That is of two lines, and that is very easy to say, which is if these are the centers of the two bodies. Now, what I mean by centers? Why cannot I say that these are two bodies?
Exactly, and that is why in order to save this concept, he introduced the idea of the center of mass. Because Newton's formulas were applicable only for point masses. This is only for point masses.
Yes, he realized that this gravitational force is acting where? Like, is it acting here? Is it acting here?
When you say that distance between the two bodies, so from where?
From where?
Yeah.
So then he came to the conclusion that, which actually NCERT also explains in a very beautiful way, and the first question of the NCERT is actually discusses this, which is, which bodies do you call extended bodies? Which bodies do you call as point bodies?
Yep.
So it says if the distance between two bodies is very large in compared to their dimension, then these bodies can be